Hello students, welcome to another session for the course Statistical Modeling for Business Analytics. Today we will review some of the statistical theory that underlies all of linear regression models. So the outline of the lecture will be like this. First we will talk about the probability framework for statistical inference. Then we will talk about estimation. Then we will talk about hypothesis testing, and finally we will talk about confidence intervals. These terms may be a little new to you, but you will understand them more as we go through this lecture. Now first we talk about the probability framework for statistical inference. Within this we will define a population, a random variable, and a probability distribution function. We will talk about the moments of the distribution, which includes the mean, the variance, the standard deviation, covariance and correlation. Then we will talk about conditional distributions and conditional means, and finally we will talk of a distribution of a sample of data drawn randomly from a population, or the sampling distribution. So let us first define some of the most basic terms: population, random variable and distribution. What is a population? The population is that group or that set of entire entities about which you are trying to understand something. Okay. So say you want to understand what is the average income of households in India. Then all the households in India are part of the population. But if you can't really sort of poll everyone, all the households of India, and ask them what is your income and try to gauge the average income for all the households in India. So you may take a sample from the entire population, but at the same time it is about the entire population that you are interested in, even though you may take a sample to understand something about the entire population. We had talked about how student-teacher ratio may affect students' achievements, and over there we had data for the school districts. We had data at the school district level. Then the set of all school districts would form the population, and out of which we had looked at data for some school districts that were chosen at random. We will think of populations as being infinitely large compared to the sample. Now we will talk about what is a random variable. A random variable is basically, it is defined as a numerical summary of a random outcome, which in the case of the example that we talked about, when we talked about how student-teacher ratio may affect the test score, the random variable was the test score, which was also a numerical variable, and the student-teacher ratio, which is also a numerical variable. You may have encountered different kinds of random variables, such as if someone says that I toss a coin 10 times and how many heads did I get. So once when you conduct this experiment the first time, that is you toss a coin 10 times, you may get 4 heads. Another time when you toss the coin 10 times, you may get 6 heads. Another time when you toss the coin 10 times, you may get 5 heads. Sometime you may even get 2 heads or 8 heads. So every time you toss the coin 10 times, that is an experiment, and the outcome is what are the number of heads you are getting, and this number of heads, this characteristic, when you put it one after another and you put the numbers one after another, that is called a random variable. It is random because you don't know what the outcome will be when you conduct the experiment any particular time. You don't know what the outcome will be. Now we come to the population distribution of Y. This is a very crucial and important concept, and I want to talk about it in details. Basically what the population distribution of Y, how it is described or how it is defined, is that what is the probability that a particular random variable Y will take a particular value in the set of values that are possible. So for instance, when you were tossing a coin 10 times, the number of heads that could come out in each of these experiments could be 1, 2, 3, 4 all the way up to 10. So, how many times, what is the probability of seeing heads 4 times? So, that is the that will be the probability. So, if you were to put on the x axis 1, 2, 3, 4, 5, 6 up to 10, the probabilities of seeing each of these outcomes, this will give your population distribution. In some sense, it is similar to the frequency distribution, that is, when you see how many people fall in different categories in a discrete random variable and you create a frequency distribution, a population distribution is the same. Okay. So, and what is the probability that your y value will take a value between two different categories. So, for instance, in this case, when you are talking about the score, the academic score, what is the probability that y will take a value between 640 and 660? This is the population distribution or the probability function. Let us draw it a bit and then we will you will understand what I am saying. So, for instance, suppose you have I will draw out a population distribution function for you. So, for instance, if you talk about the discrete random variable, that is how many times heads came up, you may have 1, 2, 3 times heads came up, 4 times heads came up, and so on. So, remember that on the x axis you are taking the values of the random variable y. These are the values of the random variable y. So, you conduct this experiment many times and you see how many times. So, suppose you conduct it 50 times. Okay. So, 50 times each time you have done. So, maybe out of those, so or you conduct it 100 times. So, suppose this is 10, this is 20, 30, 40, 50, 60, 70, 80. Okay. And suppose you got that 5 times the value of 1 came up, and then something like 15 times the value of 2 came, 20 times the value of 3 came, something like 25 times the value of 4 came. So, this is 5, this is 10, 15, this is 20, this is 25, this is 30. So, how many are total over? 20 plus 20, 40 plus 25, 65 plus 30. 5 plus 15, 20 plus 20, 40 plus 25, 65 plus 30, 95. Already you are out of your chances. So, let us actually say that you tossed it 200 times, but you may find that it's something like this. Okay, you are more likely, it is more likely that 5 times heads will have come out. So, this is called a probability mass function. Why is it a probability mass function? Because your number of times heads can come up is a discrete variable. The heads cannot come up something between 1 and 2. You know, you can't get 1.5 times heads came up, either it came up or tails came up. So, in this case, this is called a probability mass function. But basically what we are saying is that on the y axis we have the number of times a certain outcome happened. What is the outcome that is happening? That is 5 times you are noticing that head has come out. Okay. Now, if you were to, this is for a discrete variable, but suppose it's not a discrete variable, and in fact you can see that all the values are possible, then basically it looks something like this. You would have you would know the commonly known normal distribution function, and we will look at that. Okay. So, suppose you are looking at heights, and height can go between say 3 feet for adults and 3 feet, 4 feet, 5 feet, 6 feet, 7 feet, 8 feet. So, notice that we are putting it ordered from the smallest value to the largest value. This is true of all probability distribution functions. Suppose this is height in feet, height of individuals, and you will find that most people are between the heights of say something like this. So, your distribution function may look something like this, where the probability of your being somewhere between the height of 5 feet and 6 feet is very high, and the probability of this, so what is the probability? The probability of your being say between the height of 5 feet 5 inches and 5 feet 8 inches, this area under the curve, this is known as the probability distribution. This is called the probability distribution, and this particular the bell curve itself, or the curve itself, is called known as the probability density function. Okay, so this basically tells you that how likely is it, the height tells you. So, this is the on your y axis is the probability, the height tells you how likely is it that you will see people with the height between 5 feet 4 inches and say 5 feet 8 inches. Okay. So, the area under the curve tells you how likely it is that you will see a height like this. This is the probability density function. Okay. So, so this is what I wanted to talk about, and so let us go to the moments of a population distribution. So, what is moments? Moments is basically the characteristics or those values which determine what the shape of your distribution is like. Okay. So, the most common distribution that many of us often talk about is of course the normal distribution. What is the mean of the normal distribution? What is the variance? Not just a normal distribution, any distribution. What is the mean? What are the variance? What is the standard deviation? And if you have more than one normal variable, one random variable, what is the covariance between those two random variables? What is the correlation? These are terms that you know and you may be familiar with. We are quickly going to do a review of it. So, the mean is the expected value, expectation of y, that is how much do you, which value do you expect the variable to take. So, it is the long run average value of y over repeated realizations of y. What it means is that if you were to, in the case of the toss of the coin, if you were to toss the coin 10 times, infinite number of times, how many times would heads come up? So, as you know, it would typically be closer to 5 times, because you are tossing the coin 10 times. So, 5 out of 10 times. So, it would be close to, if it is a fair coin, the probability of getting your heads would be 0.5. So, that is called the mean. So, remember that it is over repeated realizations of y. It may not. If you toss it 10 times and you repeat this experiment only 2 times, maybe once you get 2 heads and another times you get 8 heads, and you say, what is going on? I did not get 5 heads as I expected. The idea is that if you were to repeat the experiment over and over again, you will finally converge to the value of 5 or 5 out of 10, that is 50%, 0.5. What is variance? Variance is a measure of spread. That is, what can you expect? Even though your mean over repeated realizations of is something, how much will individual values differ from the mean? How much of a spread can you expect in the mean? So when you talk about it over here, if you talk about this distribution, then let us draw this again. Okay. So in fact, if you have a value, if you have a distribution which looks like this, then this would be the mean, but notice that this value is different from, so this, how much can you expect other values to differ from it? That a measure of that is called the standard deviation. So this is one standard deviation. Okay, and in a normal distribution, typically one standard deviation above and one standard deviation below the mean. This much, the probability that a value will lie between one standard deviation below and one standard deviation above the mean is about 67%. Okay, in a normal distribution. If you have a distribution which is like this, instead, if you have a distribution which is like this, then the standard deviation of this distribution is far less, right? So over here it will be the standard deviation of the distribution will be less. If you have a distribution which is say like this, then the standard deviation of this distribution will be greater than the standard deviation of the normal distribution. So a measure of spread is called the standard deviation. Okay. 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 So variance is y minus, the way it is calculated is y minus mu y whole square, expected value of that, which is known as sigma y square, or it is a measure of the squared spread of the distribution. Spread means how much, what is the deviation of a given value of y minus mu y, and you square it up. Why do you square it up? Because it could be a positive value or it could be a negative value. The standard deviation is known as the square root of the variance, or sigma y. What are the other moments? Another moment of the continuous probability distribution is the skewness. The skewness basically is a measure of the asymmetry of the distribution. So the normal distribution is a symmetric distribution, but all distributions need not be symmetric. So for instance, you could have a distribution where a large number of the values, large percentage of the population have lower values, lower value of the variable rather than higher value of the variable. We will talk, I will show that to you in a bit. So skewness, when it is a symmetric distribution, the skewness is said to be 0, and when the distribution has a long right tail, then the skewness is positive, and when the distribution has a long left tail, then the distribution is negative. And the fourth moment is known as the kurtosis. So the kurtosis is really a measure of mass in the tails, even though some books call it the measure of peakedness of the tails. That is does it go up and come down in a gentle way, or does it go up very sharply and come down like that? Okay. So it is a measure of how much you can expect very large outlier values, are measure of mass in the tails, measure of probability of large values. So for a normal distribution, the kurtosis is 3. For heavy tails, that is leptokurtic, that is it is a thin at the middle and sort of spread out at both ends, that for that the kurtosis is greater than 3. So this here we talk about, here in this particular distribution, the skewness is 0 and the kurtosis is 3. So this is the normal distribution. Okay. So this is the normal distribution where kurtosis is 3 and skewness is 0. Here skewness is 0, you will see that it's still a symmetric distribution, but it is more peaked. That is, there is less probability of your being, there is less remember that the probability is the area under the curve. So if it becomes thinner over here, the area under the curve becomes smaller. Don't be fooled by the fact that, you know, over here it is going higher up, but basically the area under the curve becomes less, and the area under the curve in the extreme values, the area under the curve becomes more than over here. So kurtosis is 20. So this is called a leptokurtic kind of distribution. And over here the skewness is minus 0.1. So there is more number of values have higher, or more number of, there is a higher probability of people having higher values of the variable than lower values of the variable. Not people, but higher, more observations have higher values. And over here it is the opposite. The skewness is 0.6, here skewness is negative, here skewness it is positively skewed, and the kurtosis is 5. So in both of these cases they are slightly leptokurtic. Okay, this part of it we will discuss in the next lecture.